Okay, so we've been talking about the law of sines and the law of cosines. And yesterday I introduced you to this little table right here that represents a special case, side-side angle. This is what we call the ambiguous case, because it is possible, right, man? Andre? 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 Okay. Andre, yeah, there you go. Okay, it is possible to have two triangles with the exact same measurements. And what I started to show you yesterday was this chart simply shows you, based on your information, if you have only one triangle, if you'll have two, or if you won't even have a triangle that'll fit those measurements at all. Now, in the top row, the angle given was acute. If you're in the bottom row, then it's going to be right or obtuse. And then from there, you just go ahead and take a look at your information. Remember, if you're in the top row, you're more than likely going to need one piece of information. What is that? The height. We need to know the height of the triangle. So you'll notice, I didn't mention this yesterday because we weren't going to get to it, but you see these curved dashes right here? Okay. What this is trying to get you to visualize is that you've got the one side of the triangle kind of swinging back and forth, just like a pendulum. Okay, would go back and forth. So let me kind of illustrate for you here. Let's say I have this triangle. Okay, let me take this off right here because I'm going to need a new one. So let's say I've got a triangle that I'm trying to form. Okay. Now, if I bring the side all the way down here, well, you're going to have yourself a triangle. You got three sides to it, right? Well, what the diagram is trying to get you to visualize is that this side swings over and creates a second obtuse triangle. All right? So you can have a much larger triangle, and it can swing over and create an obtuse. That's what we're talking about. So you can have a triangle where some of the measurements are going to be exactly the same. Okay? Now, let me go ahead and just get you right to an example. Let's see what you guys think. Okay. Let's see here. La, 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 la. Here's the first one, because I believe we already worked a few of these together. We saw one where there was no solution. We saw one where there was one solution. And then we got this one right here. Okay, so here's the first example. It says find two triangles for which A equals 45 degrees, side A is 18, and side C is 24. Okay, well, the diagram given to you in your packet wasn't exactly the best. This height is an 18. You remember how I showed you that one side was swinging back and forth? This side here, the dashed one, that's what's 18. It's not the height of the triangle. Okay, so what it's saying is that this 18 side is going to swing back and forth, so it creates a larger triangle, and then it creates a obtuse smaller triangle. All right, so let's go ahead and figure out what that height is. Now, for these problems, again, we always stay consistent with our diagrams. The angle given is always going to be in the bottom left corner. Then we're going to have the side across from it because we're always going to be given a pair. The other side, make it the other top portion. Okay? So let's see. If I want to go ahead and figure out what that height is, well, what is h in 24 to 45? It's a hypotenuse and opposite. What trig function will work? We use sine. So sine of 45 degrees is equal to the opposite height over the 24 hypotenuse. Because see, we just dropped a perpendicular segment straight down to get the height of the triangle. Then we're going to times by 24. Okay. So those are going to cancel. Looks like my height is about what? Let's come over here. 24 times the sine was 45? Is that okay? 24 sine of 45. So I'm going to push enter. So 16.97, let's say about 17. Okay. All right. So let's say about 17. So this height here is 17. Now you'll notice typically our sides are going to be A and B. If they do go ahead and give you a different side like that, you know, just so it matches up with your table, just change it back to B. That changes nothing because we're always going to be creating the triangles the same way. All right. Well, how does side A compare to the height? So A is 18, the height was 17, so we see that A is greater than the height, right? How does A compare to the side we're calling B? It's smaller. 18 is smaller than 24, so I know A is less than B. And angle A being 45, we know it's acute, right? So am I in the top row or the bottom row? We're in the top row. So I'm looking for the scenario where A is greater than the height and A is less than B. So if I come on over here to the table, definitely can't be one of these. Okay. The third one. See, A is less than B, and A is greater than H. So that means there's two triangles that can have the same information. Okay. Now, I'm going to go ahead and tell you that we went through the table again just to show you how it works. I won't be giving you a problem where you have to go ahead and figure this out. If there are two triangles, like on the homework, I'm going to go ahead and tell you there are two triangles. Just go ahead and solve them for me. Okay, I just wanted to walk you through the table again to show you how to figure out if you need be. Okay, so let's go back to the problem over here. So we already know there's going to be two triangles. And let's go ahead and identify them. We're going to have a much larger one. Let me do this one in green. So we're going to have a large triangle like this. And I always draw them the same way, just again for consistency, to make things easy. Now we're going to have a second triangle. When this side swings over, that's always going to be contained inside of the larger one. So it's going to be an obtuse one. He is going to look like this. Okay, so see, this is how we're getting the two triangles. You see how I've color-coded them? So you can see exactly which is which? Okay. Well, the angle we're given, always put it in the bottom left corner. So I'm going to say this is angle A, and it's 45 degrees. Well, I'm going to do the same thing over here. Even though it's a different triangle, I'm still going to say this is A, 45 degrees. Well, what's the side length across from A? 18. So this is 18. This is 18. See, this side here that's 18, that's the one that swung over to create this second triangle. Okay. Now, the other side that we're given, again, the fact that we're calling it B, just for the sake of the table, don't worry about what the letter is, always put it as the other top side. So I'm going to say this is 24, so this side is 24. Now, if I'm going to go ahead and call him side B, then I'm going to put the B right here, and this one would be C, right? Well, let me ask you a question. Okay, one thing real fast. This angle right here, this angle B, would this be the exact same angle as this obtuse angle over here? No, so see, we don't want to call that B because we don't want somebody to think that they are the same angle. So like in geometry, we'll just call that B prime. Because across from it would still be side B, right? Okay. So the same thing here, we'll just call this C prime. Okay. All right. Is everybody okay with how I set it up? Now, from here on, everything is exactly as we've been talking about. Law of sines or law of cosines. And I'll tell you, you'll probably want to be using the law of sines more. But you can use the law of cosines if you want to. Okay. So let's start with this first triangle right here in green. What's one thing I can solve for? Okay. I can solve for what? Let's solve for B. So how do I solve for B? How would I do that? Okay, so you said sine of 45 over 18. Sine of B, because we're looking for the angle, over side 24. Remember, law of sines is just a proportion, right? How do I solve a proportion? Let's multiply. Okay, so let me get myself a room here. Cross multiply. So at this point, is everybody okay if I go ahead and just say sine of B equals, what would be up top? 24 sine of 45 divided by 18. Now, if we're looking for an angle measure, will I take the inverse? Yes. If you need an angle measure, you'll need to take the inverse. What if I'm looking for a side length? No inverse. Okay. So let's figure out what this is. 24 sine of 45 divided by 18. Oop, and I can already tell it's not going to let me, so I'm going to... Nope, you're not getting to that yet, so that is something else. There we go. So control divide. And I totally forgot about what those numbers were going to be. 24 sine of 45. Sine of 45 divided by 18. Okay. So when I push enter, 0.9428. But now remember, this is what sine of B equals. Now we take the inverse of that. We also talked about yesterday, you could just take the sine inverse of that expression, if you wanted to go ahead and do that. So sine inverse of that value. So let's say that angle is 70.5 degrees. Okay. Just the one. Remember, we only found angle B. But here's what's real. I'm sorry? Oh, now remember, this one's going to be obtuse. But I will tell you that angle is going to help me find you. Now I'm going to show you something. Once you find this first missing angle, he's going to allow you to find all three of the other missing angles. Let's start with the easiest. How do you find C? Yeah, add and subtract, right? So I'm going to take the 180 minus the 45 I started with, minus the 70.5 that I just found. So I know C is 64.5, right? So this one's 64.5. Now I'm going to use the fact that this purple triangle is actually contained inside of the larger one. Because doesn't the larger one kind of continue like this? We found this angle over here to be 70.5, right? Well, what do we know about this side that swings back and forth? Aren't they both the same length? So think from geometry. What do we know about the base angles across from congruent sides? They're going to be the same as well. So this one right here would be a 70.5 degrees as well. How does that help me figure out the obtuse angle? Remember, what's the measure of a straight line? 180. So let's see. What is 180? Oh, crap. Okay. Let me go back over here. Let me click that. Now go back over here. So 180 minus 70.5. So that is 109.5. This angle right here, 109.5. Everybody see how I use this angle to help me find the obtuse one? That will work every single time the exact same way. Okay. Now, how do I find this missing angle right here, C prime, this little one? Yeah, just subtract like we did a moment ago. So somebody help me out. What's 180 minus 45 minus 109.5? Okay. Let's see, 180 minus the 109.5 that we just found, minus the 45 that we had. 25.5. We are getting some large numbers there. 25.5 degrees. Okay. And there you go. Yes. What's that, ma'am?
I said, what do we have to find?
Yes, now all we got to do is finish off those two sides and we're done. Okay. And here's what I was talking about a second ago. We have to find side C and we have to find side C prime, right? That's the only thing left because we have everything else. So we can use the law of sines or we can go ahead and use law of cosines. What would you like? Oh, yeah, we got this one, 25.5. That's just what we solved for. This one right here? The other green triangle. Oh, this one right here? Oh, we don't need to find him. I just kind of extended this triangle to show the larger one to help you figure out how we got the obtuse angle. So, yeah, once we got that, this right here, yeah, he can disappear. Okay. He was just there to kind of help me out. Okay, so what do you want to use to find C? Law of sines? Okay. So let's stick with the original pair. Sine of 45 over 18 equals, that's the angle across from the side I'm trying to find. So sine of 64.5 over C. Okay. So now let's cross multiply. C should equal what? 18 sine 64.5 degrees all over sine 45 degrees. So someone help me out with that. Plug that in the calculator and just round it to the nearest whole number. And everything. I don't know what happened to my news. Yep. What are we getting for C? 23? Okay. There we go. And then we just have to do the same thing for C prime. Okay. In fact, I would say probably sine of 45 degrees over 18 equals sine of 25.5 over that C prime. Okay. So C prime equals 18 sine of 25.5 over the sine of 45. And if you were to go ahead and plug that in the calculator, I want to say you should be getting something around 11. Okay. And there you go. All right. What do we think? Okay, now remember, I'm not going to hold you to the table. If there are two triangles, I'm going to come right out and tell you there are two triangles. And that's exactly what I did on the homework. Okay. So let's try this one. Find two triangles for which A equals 24 degrees, A equals 13, and B equals 15. We already know there are two triangles. Okay. So I'm going to start with the same two graphs. I'm going to draw just an oblique triangle, just like this. Now the second triangle is always going to be obtuse. Okay. Now would this triangle be inside of this triangle? Yes. Okay. Now it's given me a measure of 24 degrees. Where do I always put my angle measure? Always bottom left. So this is going to be angle A, 24 degrees. So this is also A, 24 degrees. Okay, what's across from A? So this would be 13. So this side that I'm listing as 13, that's the one that's going to swing back and forth to create these two triangles. Now, where am I going to put the 15? Okay, always put it at the other upper side. Never put it at your base. So I'm going to put the 15 here, and I'm going to put the 15 here. There you go. So because this was side B, I'm going to put angle B. This is side C. And there we go. This would be B prime and C prime. See, the setup is going to be the same each and every time. Okay. Now from here, it's just a matter of solving those triangles. Okay. What's the one angle if I find I have all the other ones? Yeah, so let's find B. What proportion is going to help me do that? So tell me what to write out. Sine of 24 over 13. Sine of B over 15. Okay. Will I be taking an inverse here? Yes. Okay. So I cross multiply. Would everybody be all right if I said sine of B equals 15 times sine of, let me times in there. There we go. 24 degrees over 13. Everybody's okay with that? All right, well, let's see what that turns out to be. Let me get rid of all this other stuff right here. So control divide, we have 15 sine of 24, and what was it over? 13? Okay. So that expression is giving me 0.4693. What am I missing? That doesn't look like a degree to me. We got to take the inverse of that. Okay, so sine inverse of that value. So I'm getting B to be 27.98. So I would probably just say what? 28 degrees. I mean, that's really close. All right, so if this is 28 degrees, does this mean that this B prime is 28 degrees? No, but we can use him to find it. Okay. 128? Do you guys agree? Okay. So if I take this here, C prime, if I go ahead and draw a dash to show that the larger triangle is containing this one, we just found this one to be 28. 28 minus 180? 180 minus 28. So what would that be? 152. Okay. Is everybody okay how I went through and got those angles? Anybody confused at all? Andrea, what do you think? Awesome. Okay. So you see how this is going a little faster now? Because see, we already know what to expect. There's one on the homework where you have two triangles. You're going to do the exact same thing. Okay. Now, once we have that, and if you don't have to draw that, you don't have to, but if it helps you kind of visualize what's happening, absolutely. Let's see here. There's something I'm missing now. Okay, we still need the base sides here. Everything else we have. So, Rep, I need a proportion that would help me find side C. You could use B if you want, because now we have another pair, right? Okay, so what would that be? Sine of what? 28 over 15 equals. Okay. C, what we're trying to find. Okay. Easy, right? That's perfect. Okay. Now, cross multiply. What should C equal? What's up top? (15) sine of 128. So the sine of 28 would have to go below. Okay. So 15 sine of 128. Let's see here. 15 sine 128 over, I believe it's sine of 28. So 25.177. So let's say 25 units. Okay. Typically, your side lengths, you go ahead and round to the nearest whole number. So that's 25. And then we just want to do the same thing over here for this last one. I'm just going to go ahead and erase this so I have a little more room. Do we want to use angle A or B prime for my pair? A, okay. So sine of 24 degrees over the 13 should equal what? Sine of 4 over that little c prime. Okay, so cross multiply again. Has anybody actually figured out what that base is? It is 2. That is exactly right. Anybody having trouble with law of sines or law of cosines? Any questions? Okay. Well, there's only one more concept for me to show you, and it is the easiest thing in the entire lesson, so you save the best for last. What if, and I know you've probably been thinking about this at some point, what if we want to take the area of one of these triangles we're looking at, Mr. West? Well, I'm glad you asked about that. There are two ways to do it. One is an actual formula that's called Heron's formula. Okay? The area is going to be the square root of this expression, S times S minus A times S minus B times S minus C, where A, B, and C are just your three side lengths. So if you have all three sides, you're going to want to use Heron's formula. But there's just one thing. What's S? It's 1/2 A plus B plus C. So think back to geometry. If you had a triangle and you added all three sides, well, what would we call that? That's the perimeter. So S is just half of the perimeter. Okay. Well, let's look at an example. Find the area of triangle ABC to the nearest 10th. So I've got 44, 53, and 47. Now, before I can plug into the formula, I'm going to go ahead and figure out what S is. So S equals 1/2 A, and it really doesn't matter. I mean, the order doesn't matter, but I'm going to go ahead and keep it so here. 47 plus B, 53, plus C, 44. Okay. So what's 47 plus 53 plus 44? 144. So half of 144 would be what? 72. So now I know the value of S. All you're going to do is plug in the formula and let the calculator take over from there. Okay? So I know the area is going to be this big radical. So I start with S, which we just found to be 72, times, now I want S minus A. So 72 minus 47. Now S minus B. So 72 minus 53 times S minus C. So once again, 72 minus 44. And really, when you go ahead and plug it in, does the order matter? No, because the multiplication is commutative, so don't ever think that's going to make a difference. So here, just plug it in the calculator. Let me get rid of this real quick. So we started with 72, parentheses. Then we had 72 minus, I know there was a 47. There was a 7, there was a 53, right? Whoop, whoop, whoop. Nope. That's why I did that. Okay. It keeps doing the marker thing. Dadgummit. Whoop, I dropped my marker. Ah. All right. And then what was the last one? 44? 72 minus 44. Nope, not 444. Man, this calculator is being awesome today. All right. So is everybody okay how I plugged in? This formula is going to be provided for you. You can use your notes. I push enter. That's the area of the triangle. 978.6. And what are we talking about here? Feet. So 978.6 square feet. Okay. Now, before you use the formula, you just have to go ahead and find S, half the perimeter. Once you have that, boom, you just plug in. Okay. Now, I'm going to go ahead and skip this problem here just because we're short on time. I want to go ahead and show you the other way. Now, this one doesn't have a name, but if you have a triangle where you know two sides and the angle between them, we call that the included angle. Okay? You take 1/2 times the product of the two sides times the sine of the angle. Now, why do you think there are 3 different versions of this? Yeah, you could use it for any of the 3 angles of your triangle, right? As long as you have two sides and the angle between them. This is another way to go ahead and find the area of a triangle. Okay? So we have side, angle, side. Like I said, this one doesn't really have a lot of name. But I do like this problem because it has a lot of sass. SAS? No? That actually went over better in some of the other classes. That's true. You are not the other classes. Okay. So let's plug in. Area equals. Well, 1/2. What are the two sides that I'm given? 52 times what? 39 times the sine of the angle between them, 25.89. That's absolutely right. Somebody's already figured it out. Let me go ahead and type it in. 0.5 times, I totally forgot the numbers. 52, 39. 52 times 39 times the sine. I want to say it was 25.89. Okay. I heard someone say 442. Let's say 0.8. 442.8 square inches. Okay. Now, how do I know if I can use Heron's formula? If you have all 3 sides. Okay, so you could have used Heron's formula on this one if you wanted to first use the law of cosines to find A, and then you could plug in. But if you have side angle side, then you'll just want this one right here. Okay. All right, good. Well, let me pass out your assignment real quick. So I'm going to leave extra copies with the substitute tomorrow. So in case you accidentally lose it or you forget to bring it, whatever the case. All right. Remember, help each other out tomorrow. Work together on these problems. Help each other. Oh, I'm sorry. There we go. You're welcome. Oh, almost got it. All right. Everybody get a copy? All right. Cool. All right. Thank you guys so much again. Another great job.